He's the G word again. He just won't stop. I have found myself unironically saying golly of late. I was just gonna say, isn't his "oh gorsh"? I don't think I've ever said that. Anyway, no, that was a quote. Anyway, let's get to it. So here we go. Rational expressions. Rational expressions are just any time you have math happening and it involves fractions. But specifically, we're going to talk about math happening, it involves fractions, and it involves some algebraic variables. In other words, x's, y's, a, b's, c's, q's, z's, n's, t's, little cat emojis, whatever you want. Tim, what are you doing? Stop. Stop. I want you to put your box of Cheez-Its up there while I'm talking and stop distracting me and yourselves. I want you to pay attention. All right. This is why the class is math class, not eating Cheez-Its class. Focus. So, where was I? And you'll be the first person to be like, oh, what am I doing here? I don't know. I was too busy eating Cheez-Its. Focus. Do you like my impression of you? Would you like to hear it again? Oh, I don't know. That was me. Yeah, sure, whatever. Both of you together. Anyway, let's get back to it. I like that. Was good. That was indignant. Okay, so at its most basic, I'm sorry. Eat your Cheez-Its. It's the worst. It's the worst. No, I don't want to Cheez-Its. I'm laughing so hard I'm sweating. Okay. First things first, I hate you all. Secondly, having established, no, all of you. I just want to be very clear about that. Equal opportunity.
Does that include the viewers on your stream?
There's no viewers on my stream, but if you're out there, yes, I hate you. Now, let's get to work. Make sure to smash that like and subscribe button. So,
we want to
ring the bell.
Mr.
Okay,
Beast
shut
one
up.
day.
Be quiet. So, here we go. We've got an expression. You know how to multiply fractions. What do?
You multiply like a butterfly.
No, this isn't cross multiplying, which, that's okay. Cross multiplying would be if this looked like this, right? We cross multiply, that's a 2, believe it or not. We cross multiply when they're across an equal sign. But nope, these aren't across an equal sign. It's just multiplication. Just multiply this fraction by that fraction. Let's imagine it was, don't write this, let's imagine it was a half times a sixth. What would you do? Okay, so we do 1 times 1, which gives us 1, and 2 by, which gives us 12. Okay, in other words, we multiply the numerator by the numerator and the denominator by the denominator. Okay, good. So let's do that here. Very simple. 1 times 2 is 2, and 5 times 2 is 10, and x times x is x squared. Good. Now, that's a good answer. Nothing wrong with it. We could simplify it. How can we simplify this? What do we note? That's a good question. Is there any x's that can be simplified? No. So is the x term going to change at all? No. So the x term is going to stay the same. So it'll always be x squared on the bottom because there's nothing to simplify that with. But 2 and 10 do simplify. What do they simplify to?
1 and 5.
1 and 5. In fact, could we have done that before we multiplied? You don't have to write this, but you can if you want to. What could I have done right at the beginning here? I could have noted that what do we have on the top and the bottom?
Same number?
A 2. Could I have canceled those?
Yeah.
Sure. Doesn't matter. Right? So I could have jumped right to 1 over 5x squared, but that's pretty trivial, right? How do we feel with that? All right, you try one. Yeah.
You trying to kill me?
Because, very good question. So if we did this, when something cancels, what you're really left with is just ones, right? So that would now be 1 over 1x. And 1 times 1 is 1. And 5 times 1 is, and x times x is x squared. So when you're multiplying terms like this, do number times number and variable times variable. Does that make sense? This one down here, a little bit trickier. You've got more variables to work with. We don't just have an x, we also have a y. But you can do it. I have faith in you.
I can't. I have no idea what I'm doing.
Well, sure you
I'm
do.
gonna wait.
You're multiplying numerator times numerator and denominator times denominator. You can do it.
So would 2y times x would just be 2yx?
Yep.
That's it?
Yeah, usually we'd put that in a different order. Usually we go alphabetically. So instead of yx, we'd say,
xy.
yeah, but that's the only, but it's not wrong if you say yx. You could say y2x if you wanted. A little weird. Try it out. Worst case scenario, you're wrong. Nothing wrong with being wrong. I'm wrong all the time. Yes, ma'am. The only thing you missed is what number?
3x squared. 3 times 2. Wait, wouldn't that not go through though? Because like you're different. That's 6.
Yes, ma'am.
X squared.
I can't remember. Probably.
Wouldn't x squared times x just be x squared because we're just multiplying it by itself? Or no?
Sorry?
Actually, would it be x cubed? I'm confused.
Okay, so I want to do this question twice because I'm going to show you the two different approaches to it. And it's not that one is right or one is wrong, though I do think one is easier. So, which is, do we want to cancel first or cancel second? Let's imagine just doing no canceling at all. When we go to multiply this, we're going to multiply the numerator times the numerator, right? 2, and is there any number to change it? No. So we still get 2. Y, is there any other y here to make it y squared, y cubed, or anything like that? So it's just going to be y. And then x, is there anything there to change it? So it'll be 2yx. We said that less clumsy, we usually put them in alphabetical order, so 2xy might be better. But I don't care which one you do. And if it helps you to start on this side and go, 2yx is fine. Doesn't matter. Now let's look at the bottom. When we multiply these, we do the same thing. What should we start with? The numbers. So what's that?
6.
3 times 2 is 6. Good. Now let's look at our x's. How many do we have here? Yeah, so x squared. There's 2 of them. We're multiplying by another one. How many x's do we have multiplied now? 3 of them. So x cubed. How many y's here? None. And then over here? Yep, for a total of 1. Awesome. That's an x, by the way, even though it doesn't look remotely like it. Now, can we simplify anything here? Well, to 2 and 6 simplify to anything? What can you divide them both by?
2.
We divide them both by 2. And when we divide them both by 2, what do we get? What's going to be on the top now? 1. And on the bottom? 3. Okay. Anything else that cancels? Yeah, we have a y there and we have a y there. So are we going to have y's at all here? No, not on the top or the bottom. They both canceled. What about the x's? We have an x here, right? How many do we have on the bottom? 3. How many of them can we cancel? 1. So what will this be now? X squared, right? We had 1 x on the top. We had 3 x's on the bottom. So what are we going to be left with down here? X squared. How is that canceling? Not too bad? Now, having said that, my preference, and that's totally valid, multiply top times bottom times bottom, get it, and then cancel it. I think even easier, and like Solange jumped right to this, so she's probably done this before, or she's just brilliant, or both. Both could be true. So the other thing we could do is we could cancel right here. We have a 2 here, and we have a 2 there. So what do?
Cancel.
They cancel. We have an x here, and we have an x there. So what do? Cancel. And we have a y here and we have a y there. What do? Cancel. Does that make sense? And so what remains? What remains on the top is actually nothing. But when you're multiplying and dividing, canceling doesn't leave us with 0, nothing. It leaves us with 1, right? Because anything divided by itself is equal to 1. So when you cancel in multiplying and dividing, you're left with 1. And then what remains on the bottom?
3x squared.
3x squared. Is one of these a better solution than the other? Absolutely not. It's just whatever you find easier. Does that make sense? One thing I want to note, though, when you have fractions multiplied by each other, you can treat it as one big long fraction. Does that make sense? See how I canceled a 2 from the numerator of the first fraction with a 2 from the denominator of the second fraction? That's totally allowed. That's perfectly fine. You can do that. See how I canceled the x with this x. Could I have canceled one of these x's if I wanted to? Yeah. You can cancel with numerator and denominator. They don't have to be from the same fraction as long as they are being multiplied. Not if you're adding or subtracting. That's totally different. But if you're multiplying, it doesn't matter which numerator, which denominator, you can cancel. Does that make sense? How's that feel? Not too bad? Awesome. It doesn't ask this, but if it did ask, are there any restrictions on this? Is there anything x can't equal? 2 would be fine. 2 squared is 4. 4 squared times 3 is that. Negative 2 would be fine. Negative 2 squared is 4. 4 times 3 is 12. In this case, x couldn't equal 0. Because 0 squared is 0, and 0 times 3 is 0, and you're not allowed to divide by 0. Does that make sense? The question didn't ask that, but not a bad idea to remember. Does that make sense? So if this were a function, that would be a restriction on the function. You can't divide by 0. You don't need to write that. We didn't need to know that. I just thought it was worth mentioning. Can we try a trickier one? Okay.
Can we try this ourselves?
Yeah.
Okay.
Sure. I just want you to expand. I'll tell you right now, nothing's going to cancel. Because if it was going to cancel, it would cancel in this form, in factored form, right? Can you cancel the x's? What is going on here, remember, is that even though we don't draw it, what is actually present in each case here? Brackets, which means you would have to do the addition or subtraction before multiplying or dividing. So you cannot cancel x's like that, which, look here, you know this. Because, look here, if we had 3 plus 2 over 3 plus 8, is that the same thing as 2 over 8? Can you cancel those 3's? Well, let's check. What is 3 plus 2? 5. What is 3 plus 8? 11. Is that the same thing as 2 over 8, which is a quarter? Are those the same? No, of course not, right? So if there's addition or subtraction, you can't cancel. You could cancel the whole thing. So if this said x plus 5 instead, then you could cancel those two whole things like that. Does that make sense? But it doesn't say x plus 5, it says x plus 2, so there's no canceling. So you're not going to get any canceling on here. This is just going to be expanding. All I want you to do is expand.
Because we do numerator times numerator.
You do numerator times numerator and denominator times denominator. So you can do that.
Split these two apart.
My division line is too long. Focus. Have they finished? Quiet, Cheez-Its. Cheez-It A and Cheez-It B. Coming to take a Cheez-It.
They're really good. They're ranch.
You and you and you and you and you and you, you're all right. You, she's okay. You're okay. You, you're okay. Sorry? Do you see him chewing on Cheez-Its back there? Do you see him while I'm trying to teach, like, crinkle, 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 look at me. I'm looking down at a box, crinkle, crinkle. No, I've never seen it. In fact, once I saw him on his phone, and I went and yelled at him, and you know what it was? Do you know what it was? It was a calculator. It wasn't a phone. He was doing math. Yeah. So why would I get after him? I wouldn't. That's why. Yes. In university, you wouldn't want to assume that you could. It'd be depend. It would. I would guess it would vary class to class. But here's the deal: don't be the first.
Oh, okay.
You know, you want to, because most profs would not be cool with that. Some might, but it would be definitely not an assumption you want to make. Because it's not done. Like, the answer is not everything's about. Some things are also just about what isn't done. In other words, like, how would eating hinder a court proceeding? It wouldn't, but boy, don't be in a court proceeding and start eating. You know, it's disrespectful, I guess, is the answer, right? And so something like a professor, like, there's a piece of, like, you know, these people are experts in their field, and the answer is, like, it is disruptive, right? Like, you saw that, like, this twinkle, twinkle, and trying to go. But that's inevitable. Like, you know that, right? Like, if people are eating, that's going to happen. But it's also just disrespectful, right? Like, that professor is there, they have years of training, they're an expert in their field, sometimes very, very elite in their field, and they deserve your attention and to be your focus, and you can go an hour without eating, I guess is the answer, you know? But it's also just a sign of respect, and in the end, you know, the person has power over your grades. They're giving you something, which is knowledge, but also grades, certificate, you know, diploma, and you're giving them something, your attention and respect. Yeah?
So the bed's making noises. Is that because there's atoms moving around?
Be quiet. Absolutely be quiet. Nothing wrong yet. All right, let's expand this. Now, binomial expansion. We're going to do the top one way and the bottom one a better way. All right? For the top here, what's x times x?
X squared.
Okay, x squared. And then what is x times negative 7?
Negative 7x.
Negative 7x. Good. What's 5 times x?
5x!
Nope. Nope, thank you. Plus 5x. Good. And then what is 5 times negative 7?
Negative 35.
Negative 35. Good. Okay. There's nothing wrong with that, but we should know binomial expansion by now. Because, of course, what do we have to do now? We need another line, and in that line, what are we going to do?
Oh, I just skipped ahead to this part.
That's okay. What are we going to do?
I did sum and product rule.
Collect like terms. And what will the like terms be? X squared, and then these are like terms, so what do we get?
Minus 2x.
Yeah, minus 2x, negative 2x, and then negative 35. Okay, that's totally fine, and there's nothing wrong with that. But I do want you to start noticing, okay, this is a binomial. We know how binomial expansion works. How did we get this negative 35 from this?
Because we did 5 times negative 6.
Yeah, you multiplied those two numbers. So how will you get the last number for this one? What will it be?
The product.
Negative 6, right? You'll multiply these. Obviously, why did we get x squared at the beginning? Because it's
X times x.
x times x. Okay, now, don't shout it out. Shh. How do we get this number? Where did it come from? Well, we put these two together, right? In other words, what did we do with these two numbers to get the x term? Cool, now you can shout out. What do we do with them?
What we do is we did x times negative 7, which equals negative 7x.
Yep, beautiful.
And then we did x times, 5 times x
Yep.
in that order. And then we got plus 5x. And then we collected like terms, so we kind of put the two together, and we ended up with negative 2x.
God's lips to your ears. There you go. Exactly.
Personally,
That's
I
beautiful.
use the sum and product rule.
Yeah, it's some product rule. That's good, right? That's good. Yet another person who should be doing this instead of me. So let's just save ourselves a step. What's this number here? We have negative 3 and positive 2. What will the middle term be?
Negative x.
Negative 1x, or even better, just negative x. All right, and there we go. We get x squared minus x minus 6. All right, now, that is the fully expanded version of this. These are both valid. This would be factored form, which is valid. This would be expanded form, which is valid. Which one you're asked for depends on what the question asks you to do. Does that make sense? There would be no point in us refactoring this because, A, we already know it in factored form, right? There it is. And B, the main reason we would factor it is to see if something cancels. And looking at it here, did anything cancel? No. Does that make sense? But just be aware that these are just two different forms of a rational expression. You can have a rational expression in factored form, and you can have a rational expression in expanded form. And sometimes we will work with one, and sometimes we'll work with the other. Sometimes we'll have to work with both. With this one here, we could just expand it, right? Now, if we expanded this, it would get pretty ugly, wouldn't it? Right? Because we would have to do x times x squared, then we would have to do x times 2x, then we'd have to do x times negative 15. Then we would have to do negative 6 times x squared, negative 6 times 2x, and negative 6 times... Now, can we do that? Absolutely. How many terms will we get? Specifically? 3, and then 3 more for a total of 6. And then we do the same on the bottom, right? We may have to do that because this asks us to expand this. But what would be a good idea to check first to see if maybe we can make this a little easier? What might happen?
Cancel?
Something might cancel. And to know if something cancels, what will we have to do? Try factoring. Does that make sense? We're going to try factoring. So what we're going to do, this is already as factored as it can be, right? Can we factor x minus 6?
No.
No further. Can we factor x plus 5?
No.
No. So we only have 2 things to check here. There's the first one. X squared plus 2x minus 15. If we want to factor that, we know what it's going to look like. No numbers yet. What's it going to look like? How many brackets? 2. What's going to be the lead off in both those brackets?
X.
X. Good. Take a minute. Get the numbers for me. Don't shout them out. Take a minute. Get the numbers for me. Talk to each other. This isn't a test or, whatever. Chat with each other. You can say, hey, Sam, ask me a Cheez-It. Also, what did you get? I don't actually want Cheez-It. I mean, the delicious thing. Huh? Yep, but in this case, do we need AC? Because the A value is just, it's 1, right? So it's not there. But having said that, yes, AC rule we use for factoring. Do you see how I told you, by the way, that not to ignore factoring because it wasn't going to go away? It's not going anywhere, team. It's just going to keep showing up. Is that just stretching or is that a hand? Excellent. Let me come to you. And then, but don't think equals that. Like, if that makes sense. Like, this is like a sidebar. We're just figuring out what the stop is. Does that make sense? Like, you could even, it's fine where it is, but you could even work even more over here. Like, we're just doing that so that when we say when it's equals, we'll now replace the top of that fraction with this. Does that make sense? Cool. Oh, the only thing, remember the 2 sides. You got the right numbers. Why did you choose 6? Is that positive 3 and the negative 5? Very close. Add together. Positive 2. So which one should be positive? But other than that, good. Does that make sense? Awesome. How's that for you? Beautiful. I'll just keep adding to the bottom. And yeah, I should mention, guys, when I do this little highlighting bit, I probably should have written this even further to the side. I'm not really working with this equation at all. I'm just trying to figure out how do we factor just that top little bit. Does that make sense? What numbers did we get? We needed 2 numbers that multiplied to... What? No, it's okay. What do they need to multiply to? Yeah, negative 15. So what are the options? Obviously, negative 15 and 1, negative 1 and 15, negative 5 and 3, or negative 3 and 5. Any other? That's, I guess negative 7.5 and 2, negative 2 and 7.5, but we're getting silly here. What's the pair? Yeah, positive 5, negative 3 works, because what do we want to add to? Positive 2. Good. So what are these brackets then? And? Awesome. So we can start to rewrite this expression. And for the top of this first fraction, instead of writing that, I can write x minus 3 and x plus 5. And before we've even done the other one, we have already found what?
Something that cancels.
We've already found something that cancels, right? That x plus 5 is going to cancel with that x plus 5. Do we see that?
Mm-hmm.
Awesome. All right, now let's look at the bottom fraction, or bottom the bottom polynomial expression. X squared minus 9x plus 1. Is that going to factor? Is it?
Oh yeah, that is gonna affect because.
Oh, does it? Why does mine not? So I was going to say, I'm surprised I picked a number that wouldn't factor, but it turns out I picked a number that factors. So yours says 18?
Yeah.
Why the heck does mine say 1? That's okay. Well, 18 does factor, so that's way better. I was getting annoyed with myself in real time, but here we are, and I'm happy with myself again. And you know who I can be annoyed with?
Me.
Copier 1. Do you see, by the way, do you guys see, oh, no, this isn't a copier 1 thing. This is a OneNote thing. Never mind, because your copies are fine. Damn you, OneNote. Are you going to go on notice? Putting OneNote on notice. Okay, there we go. Let's get to it. They know what they did. Godless killing machines, bears. Anyway, not the Bears, just bears in general. Now, that can include the Chicago Bears, I guess, by the transitive property of bears. But anyway, we'll move on. So, yeah, we need two numbers that multiply to... Is it plus 18 or minus 18, by the way? It is plus 18?
Plus 18.
Oh, good. Okay, so the options would be 18 and 1,
No.
right? Well, yeah. Negative 18 and negative 1.
Not it.
9 and 2.
No.
Negative 9 and negative 2.
No.
6 and 3.
No.
Negative 6 and negative 3. Yes, there we go. Okay. Cool. So how do I rewrite that then? X
minus. Well, this is how I wrote it.
X minus 6.
I did it the other way.
That's okay. And X minus
3.
3. Okay. Like, if you were finding the roots, you're absolutely right. If you're saying what are the roots of this, then 100%. The roots would be x equals 6 and x equals 3. But we don't, like, switch the numbers when we put them into the brackets. That's how you solve for roots. That's okay. So that is, one sec. So that gives us x minus 6, and this one gives us x minus 3. So, what does this work out to? What do we notice? What else cancels?
Everything.
X minus 6 cancels, and x minus 3 cancels. What does this whole thing equal?
1.
1. Not 0, because 0 is what you get when you cancel things out by doing what operation? No. Adding and subtracting. If you take everything away, you get left with nothing. But when you divide everything equally, it means everyone gets 1. Right? If I bought 20 donuts for a class of 20 kids, everyone could have 1. If I bought 11 donuts for a class of 11 kids, everyone could have
0, because I stole all the donuts.
Well, that is one of the outcomes, yes. But the other outcome could be that everyone would have 1, right? When you divide, things default to 1. Okay, there we go. How's that feel?
Pretty good.
Not too bad? All right, how do you divide fractions?
Oh, you butterfly. Oh, wait, no, you didn't do that yet. I'm
What?
sorry. I'm like
It's okay. It's okay. I've never heard butterfly before, but it's a pretty image. And I'll remind you that if you get stressed out, oh, you're right. Oh, that's not cute at all. Oh, no, not cute. Oh. It's adorable.
Yeah, I crossed him out.
I love
He was
owls.
gonna kill me.
Okay. What do you do when you're dividing? Keep in mind, what is each of these fractions? A fraction is another way of saying division. And in fact, what's the division symbol? Notably, it's saying, hey, this is a fraction. Put this on the top of the fraction and put this on the bottom. Now, the problem there is we could indeed, don't look at me. Put your pens down. Don't write this. Put pens down. We could do this. 10ab squared over 4a all over 15a squared over 12b squared. This is perfectly valid as a solution to that. Is that going to be helpful?
Looks stupid.
Oh my God, no. It's going to be horrifying, right? So we could do that, but we're not going to. Instead, what's the algorithm? What's the rule? What do we do? Yeah, what do you do? Yeah, in other words, this is saying take 10ab squared and divide it by 4a, right? Then it's saying divide it by 15a squared, but then that 15a squared itself is divided by 12b squared. But all the same, it's actually saying take this and divide it by that. You know what I mean? If you ignore the bottom for a second, this says take this and divide it by that. In other words, you would have 10ab squared up here, right? And then you would have 15a squared down there, because this means to divide. Does that make sense? So, this fraction, another way of saying it is just this is going to end up on the bottom. Now this, what does it mean to divide and then divide again? Well, what's the opposite of dividing? Multiplying. So this actually ends up being multiplied. So when we get a fraction, what we do is we flip the second fraction, and now it's just a multiplication question. Right? Super easy. It's adding and subtracting fractions that sucks. Multiplying and dividing fractions is easy. So we would just rewrite this as 10ab squared over 4a, and we would multiply that by what? Yeah, which is 12b squared over 15a squared. So what we do is we flip the second fraction, and this becomes multiplication. You mean cross-multiplying? Because cross-multiplying is just a trick like any other, and that is the trick for when you have, if it was this, which it's not, if they were equal to each other, it's okay, don't be sorry. That's when you use the cross-multiplying trick, but that's not what we have here. But that's when. You do it when two things are equal. When things are multiplying, you just multiply numerator times numerator, denominator times denominator. And when it's division, you flip the second fraction and you change it to multiplication. And now we just do numerator times numerator, denominator times denominator. But hey, before we do that, does anything cancel? No, I think lots of things cancel. What cancels? That A cancels with that A. I like that. And then, can we simplify this? 10 and 4, what could we divide them both by? 2, which would leave us with 5 and 2. I like that. Can we simplify this? 12 and 15, what can they both be divided by? 3, that would give us what? 4 and 5. Hey, wait a minute, does anything else cancel?
B squared and B squared?
They don't cancel, they're on the same line. The 5 and the 5 will actually cancel, won't they? That 5 can cancel with that 5. All right, now let's do this. What are we left with? This number on the top is just b squared, and it's being multiplied by b squared, which will give us what? B to the power of 4, right? 2b's there, 2b's there, 4b's all together. There's no number here. The number here is 4, so the number will be 4. There's a 2 here. There's no number there, so the number will be 2. And there's no variables here. There's an a squared here, so this will be a squared. We can actually simplify this a little bit further, yeah. What did we do here to get 5 over 2? How did we turn 10 over 4 into 5 over 2? We just divided the top and bottom by 2. That's just simplifying a fraction, right? And how did 12 over 15 become 4 over 5? We just divide them both by 3. Does that make sense? Yep. Do you want me to write that? Divide by 3. Divide by 3. And over here, we'll say divide by 2.
Question.
Divide by 2.
Because
Yeah.
the answer, everything in that answer is divisible by 2.
You're right.
Do we also divide the exponents? So would it?
No. These exponents don't cancel unless they are to the same power, the same base. And the base on this one is
2, 4.
The base on this one is B, and the base on this one is
A.
So they have nothing to do with each other. So you can't simplify them. Now, if these were both A's, then you're absolutely right. Then we would cancel. But because one of them is an A and one of them is a B, they're different things, and you can't cancel different things. Now, having said that, what can we divide the top and the bottom of this by?
2.
Divide by 2, divide by 2. That's going to cancel that, and that's going to turn this into 2, right? But I'm going to just, so say over here, on the top, we would have 2b to the power of 4, and what's left on the bottom?
A squared.
We could write 1a squared. Do I need to write that 1?
No.
No. So we would, by convention, just write 2b to the power of 4 over a squared. You should have learned negative exponents last year, yeah? So if you wanted to, how else could you write this? You could write this as 2b to the power of 4, a to the power of negative 2. Does that ring a bell? Do you remember negative exponents? You did them. I promise you did them. You did them in grade 9. That was like 6 years ago. A negative exponent is just another way of saying actually this is division, right? Because we know a positive exponent means multiply that many times. So a negative exponent means divide that many times. I'm just going to mention it because you will come across them. If you see a negative exponent, usually what we do is we just turn it into a fraction. We shove it in the bottom, and now the exponent can just be positive. Does that make sense?
Can you? Whoa. Okay. I'm gonna try to make sense here.
Okay.
Sorry. So the 2b4
Yeah.
over a2, you can reverse back to the original 10ab and 4a, right?
If you wanted to, yeah, you could multiply the top and the bottom by 5. Those yeah. Yes, but there's been a lot of canceling happened. Yes, you could work your way back there, but you'd have to undo everything we've done. I don't know how you
do that in a question.
I mean, no, that doesn't really, because you can't really know. I mean, no. But I mean, you could do it, but I don't really know why you would ever want to unsimplify something. But if I said unsimplify the heck out of this thing, yeah, you could do it. Because if you want to, could you multiply the top and the bottom of this thing by 11, and then put a z squared on the top and a z squared on the bottom, and an x minus 8 on the top and an x minus 8 on the bottom, and then multiply it all out? Yeah, sure you could, but you wouldn't want to. It'd be a big waste of your time. But you could do it. Did that answer your question?
I just wanted to make sure you wanted to do that to us.
Okay, you try this one.
Thank you.
Just like we did above. Remember, the only thing we need to know is, what do we do with a division sign? Nope.
Cry.
What do we do? Quiet. We flip this fraction, and as soon as we flip that fraction, this isn't division anymore. It's multiplication, right? To do that. You got it. Yeah. Yep.
Can you cancel exponents?
Only if the bases are the same. So
right.
b to the third over b squared, those will cancel. But b to the third over a squared, you leave them alone. The base has to be the same. Isn't it? Well done. And in one step. I'm not going to do it in one step, but good for you.
Hold on. So, I have a question.
Yep.
So, even if the bases are the same, do the exponents also have to be the same?
No. No, the exponents of the part. Remember, all an exponent, like x squared just means this is x times x. So you have two of them that you can cancel. So one of them can cancel with that one, and then there's no other ones to cancel. So that would cancel with that, and it would leave you with, instead of two x's up here, just
X.
one of them. Yeah.
But I tried canceling the
These
X.
ones make more sense to cancel, right?
Well, I already screwed up.
No, you didn't screw up. Just there's lots of ways to get the right answer, and there's lots of ways to get the wrong answer.
Well, I mean, I don't think he's ever be mad at you. I just mean like, no, you're both girls.
Yes, but this one's
No,
Y.
he's a girl. I chat this talk.
So then it would be one Y on the side of the face.
And if you get wrong here, I will let you. Just throw it. I'll take it up.
Yeah.
Oh, there it is. He's still very pissed at you. He said that if you try to apologize to him, he might call you some not so nice names. Honestly, I wasn't planning on apologizing because I don't think it's gonna involve me. Yeah, it's not. Just like pretend he doesn't exist. Well, how can I pretend when she makes one of my friends so happy? I don't know. Do you want to see them later? Yes. I'll show you after. For like maybe environments.
What? That's crazy. Wait, can I
Where the heck did Orlando go?
What the hell?
I don't know if I did it.
Oh wait, I forgot. Wait, that's on me. That's on me. I forgot to put the chore.
I need to find myself a woman. Guys, we need to help find Alex Minky a sugar mommy. I don't know. Excuse me, what? No, he literally said that's
Is that actually like his last name?
Yeah.
It sounds like a slur. Like, I
It
don't want to
does.
say
It
it.
does.
Maggie. Guys, let's all stick to our math work.
They're not the teacher people.
No, girl.
I'm so trying to ignore you, Alex. He keeps saying Dorios on Instagram, and I can't stand it.
He sent me a reel about this kid like licking ketchup on their father's back or something like that. Like, what did you even send me, Kartik?
What did I send you?
I don't know, just send me this thing where these guys like putting ketchup
The
on
stuff
their
that
desk.
Titan sent me is the worst stuff
So
ever.
bad.
It's terrible. I am this close to blocking it.
Okay, I thought it was
So bad.
It's terrible.
you know, that guy's shirt was really.
You just sent me video.
Like Jordan Murray's worst.
It was related to it.
Are you okay?
I would buy your sleepers losing diapers. So, we're doing this right. I know it's just straight.
Sorry. Please keep walking.
Keep walking. Keep walking, please.
So
So,
you feel so much shame. That's what happens. When
it
people
wasn't me,
get
guys.
around to you, and you guys hold it all the time. And then they
All right,
look
how we doing, team?
Orlando, I got a question.
Yeah.
Would the y squared cancel out with the y squared here?
Let's find out.
How did you
okay,
get a 7?
it would be 14 after. I'm wrong.
That was not the answer I was hoping to hear.
Well, let's take a look. All right, so team, what's the first thing I have to do? I have to flip this fraction. So how do I rewrite this? This should read as, that's too big. Listen, if you're wrong, you're wrong. That's a big part of doing math. Does the first fraction change?
I didn't even finish the question because I just didn't know.
So we write it the same way. The second fraction is the same,
You forgot
except
the cube symbol.
the bottom becomes
You forgot the cube
the top.
symbol.
okay. And then on the bottom, what do we have now?
4x squared.
Okay. Now listen. I sometimes find it easier to deal with numbers later if they're not the same. You can decide for yourself. But what obviously can cancel here?
The x's?
This y squared can cancel with what? Can it cancel with this y squared?
Yes.
No, because they're both on the top. They're going to get bigger, right? When you multiply, they get bigger. What will they cancel with, though? Yeah, no, will it cancel all of them? No, it'll cancel 2 of them, right? So that would leave just one y, right? Oh. Now, do we have more y's we can cancel? Yeah, we have how many left here? 1 right now, and how many up here?
2.
So we can cancel that one with one of those, leaving us with 1y up here. What about x's? We have an x here. We have 3 x's to choose from. Does it matter where we cancel? Could I cancel with one of these ones if I wanted to? Could I say that cancels with that? I could, though what's obviously an easier thing to cancel it with?
The bottom one?
Yeah, the one right underneath it. How's that? Cool. Now, there's also a number that cancels, I think. Or it doesn't cancel, but what can we... This 4 and this 6 jump out at me. What can we do with them?
Divide by 2.
Divide by 2, which would leave me with what here? 3, and here 2. Okay. Is that pretty messy? Yeah, but that's okay. What's 3 times 5?
3 times 5 is 15.
15. Do we have any x's left on the top?
No.
No. Do we have any y's left?
Yeah.
Yeah, how many? 1. Do I need to write the 1?
No.
Could I write the 1?
Sure.
Yeah. Try and stop me. What did you do if Sam came up and just did stop me? Like I went to write the
You know
1 and
what?
she just knocked
Do
me
it.
out.
Do it. Write the 1 at the top. Do it.
Yeah, you won't stop me.
You did it.
Sam, could you apologize?
Yes, ma'am.
How do you erase?
Just with the back of it like an eraser.
Here you go.
Tell me not to do it again or I'll get what's coming.
If you do this again, Mr. Orlando, we're gonna have some serious problems.
Yes, ma'am, I won't, I promise. All right, looks like she stopped me. All right, what about the bottom? What numbers do we have? We have 7 times
2.
which is? 14. Do we have any y's left on the bottom?
No.
That x is gone, but what do we have here? X squared. There we go. So we get 15y over 14x squared. How's that? Did anyone get that? Nice. If you didn't, don't stress about it. This is tricky. It's new stuff, right? But how's it feel generally? Does the canceling bit make sense? All right. It takes some practice. So you're definitely going to want to do the homework on this one. But now, of course, we got to try this last miserable bit.
What am I looking at?
Okay, so the first thing is the same trick. When we see division with fractions, what do?
Flip over the second.
We flip the fractions, and that becomes multiplication. All right, don't even think about it. Just do it. The top of this one is 2x squared minus 8x. Bottom, x squared minus 3x minus 10. Then we multiply that by x squared minus 9x plus 20. And what's on the bottom? 4x squared. Okay, now, we could start multiplying. How many terms are we going to end up with if we do that? Lots, right? We'd have to multiply all these and all those, right? Can we agree that's going to be miserable? So what should we try first? Factoring to see if anything cancels. So let's just start. This factors pretty easily. What can both of those be divided by? 2. What else? Can both be divided by x. What's that leave in the first term? We took the 2 out. We took one of the x's out. What's left? x. Minus 8, but we divide it by 2, so we're left with 4, and we took the x out. So that's it. Awesome. That one was pretty easy. I didn't hate that. That is the top there. So we can write that as 2x, x minus 4. Cool. Let's keep going. Do you want to do, should we get this done, do the bottom of this one as well?
Yep.
Okay, let's do that. What do the numbers need to multiply to?
-10.
Negative 10, what could that be? Could be negative 10 and 1, negative 1 and 10, negative 5 and 2, or negative 2 and 5. Which one works for us? Negative 5 and 2. So what's that factor to? X minus 5 and x plus 2. Now, do you see how we're getting to the point where we stop writing a whole bunch of stuff for this simple factoring? Right? This is why I said we got to start to build some facility with that, right? Because if every one of these factorings takes you 6 minutes, a question like this becomes a nightmare, right? So down here we have x minus 5, and we have x plus 2. Anything canceling yet? Nothing yet, right?
No.
Okay, next thing. Let's do the top of this here. What numbers do we need to multiply to here?
20.
20, all right? And that could be negative 10 times negative 2, negative 5 times negative 4. Which one is it? I guess negative 20 times negative 1. By the way, why am I picking all negative numbers here? Because the middle term is
A negative.
negative, right? But I made them both negative because the final term is
Positive.
positive. And when you multiply two negatives, you get
Positive.
positive. So which one's the pair?
-5 and -4.
Negative 5 and negative 4. Oh, looks like I was crossing it off. When really, it's what I wanted. So what are my brackets here? X
X minus 5.
x minus 5, and x minus 4. Cool. And where's that living? On the top. So x minus 5 and x minus 4, right? And then what's on the bottom here? 4x squared. All right. Does everything cancel?
No. But
No, not at all. But do some things cancel?
Yes.
What cancels?
The X minus 5.
X minus 5. What else?
The X minus 4.
Does it? No, because they're both on
The top.
the top. And when you multiply something by itself, does it cancel? No, in fact, it just becomes squared. What else cancels, though? 2 and 4, do they cancel?
Yeah.
Yeah, that'll just go away, and this will become 2. In other words, I divided them both by 2. What else cancels? This x will cancel with one of these x's, right? Does that make sense?
Yeah.
All right. So what we're left with is what? On the top, we have x minus 4 times x minus 4. And on the bottom, we have 2, right? And then x, and then multiplied by what? X plus 2. There we go. Is there a cleaner way to write this? There's a cleaner way to write the top of this for sure. What should I write? X minus 4 squared. X minus 4 squared over 2x, x plus 2. Now, could we expand this out if we wanted to?
Sure.
Yeah. Do I want to?
No.
No. But we're gonna, just if we wanted to. Or if we wanted to, we could say it's equal to, and we're not gonna do any big carrying out. When we square something, what do we get? The first term will obviously be x times itself, which is x squared. The middle term will have x times negative 4, and we'll have negative 4 times x, which gives me a total of how much? What do we do to get that middle term in a perfect square? It's what of this number? It's that number. Half when we're going backwards, so when we're going forwards and actually squaring it, we multiply it by 2. So this will be how many x's? Negative 8x. Good. And then the last term, what do we do with that number? Multiply it by itself, which is 16. Good. All right. And then if we do the bottom here, what's 2x times x? 2x squared. And what's 2x times 2? Plus 4x. These are both valid answers. Which one do I like better? No, I like the first one better. Just leave it in factored form. Unless I tell you to do this, don't bother. Unless told to expand, don't bother. because there's no way anything will cancel. You know what I mean? Once it's in factored form, it's no different there. By the way, if I wanted to check and make sure I had done this correctly, what could I do? Yeah, what would I put? I'd put the original question into Desmos, and I would put my answer. Does that make sense? So let's just quickly do that, because it is super helpful to be able to check your work. Now, the only thing about Desmos is I'm going to have to skip. Look here. There's no real way to put a division symbol in Desmos, so I am going to have to skip to the second step where I had flipped them and made it multiplication. Does that make sense? Because if you try to divide in Desmos, it only works in fractions. So we're going to just, we're just going to not bother with leaving it like that. But there's the original. Isn't that a fun-looking function? That look kind of goofy. Isn't that fun? And now we put our answer in, and it should be the same. X minus 4 squared over 2x, x plus 2. Hey, look at us. See that? What's that mean? We did it? Because these two expressions are what kind of expressions? Equivalent expressions. Does that make sense? Always check your work with Desmos. It's so easy, and if they don't match, you screwed something up. You won't always know what you screwed up, but at least you'll know you screwed something up. Okay, you got 7 minutes left. That's plenty to try this last one. So try this last one. Yep. Yeah, give me 1 second. But yes, absolutely. And just a reminder, when we see division with a fraction, what do we do with that? Make that multiplication and give her the old flipperoozy. Yeah. Let me see. No, not you got to factor. Everything has to be factored. You can't. It doesn't matter if it's the same sign or different sign. You can't factor cancel anything here because this is the subtraction between these, and there's addition between these. But then there's also subtraction 15. It has to be in factored form. You can only cancel in factored form, guys. You can only cancel in factored form. What's the only form you can cancel in?
Not really. But it's just like a good skill to have.
Sometimes you'll have to expand it because I'll say, express your answer in expanded form. But if I don't say that...
Oh, and if we want to check it like in Desmos, do we have to expand it, or can we just like put it in like...
No, I didn't expand it, right? If you look here, I just put in... Now, if I want to check and make sure I expanded properly, I could put that in too, right? So if I wanted to, I could also plug in, and this should make the exact same fraction, or the exact same function. And lo and behold, what do we notice? All three are identical because they're equivalent expressions.
I got a question.
Yeah.
So, because I'm dividing the x squared by 2 to
Yep.
just get x. Does that mean this will be x minus 1 because I'm also dividing this?
No, you're not. You haven't divided by 2. You've just divided by x.
Oh, okay.
Right?
So that good thing I wrote.
Yeah, no, you did exactly right. That was perfect. All right, guys, I'd love to give you a bit more time to work through this, but I want this example done in your notes before you go. So, sorry, if we hadn't spent so much time talking about Cheez-Its at the beginning, maybe we'd be done this question. But hey, that's fine. That's fine. You can thank your delicious ranch-flavored snack for your lackluster education in mathematics.
You were literally laughing.
Yeah, because it was funny. That doesn't mean it wasn't a waste of my time. Now, let's get to it. What's the next line of this? This will be the same, right? X squared minus 2x over x squared plus 2x minus 15. And then we change this to multiplication, and then we got to be careful. What goes on the top here? Yeah, x squared minus 2x minus 3. And on the bottom? X squared minus x minus 2. Okay, now, we want to carry on here. What we need to do is factor. Some of these you might be able to do in line, But this factors pretty easily. What do we get? What can we divide both these by? X. And this one with an X taken out would be X. And -2 with an X taken out is just -2, right? So that should be X times X minus 2. Let's do the bottom of that fraction. What's this going to be? What numbers are we looking for? Two numbers that multiply to -15 specifically. And that's going to be 5 and -3, 3 and -5, 1 and -15, 15 and -1. Which one works? That one, right?
That's all on today's cafeteria menu. Make it a good day, Eagles.
Carbs on carbs today, guys.
Sign me up. You know what I love? Carbs. You know what I like them on? Other carbs. Ideally with some bacon.
Ideally with some more carbs.
I'm Italian. It's all about like, hey, like last night, you know what I made? Lasagna. You know what I had with my lasagna? Bread. Is that smart?
Yes.
No. Is it delicious?
Yes.
Yeah. Yeah, it is. All right.
And just one more
No!
announcement. When the bell rings, could the following students please head to the resource room? Olga Blackbeard, Leisha Shelton, Katrina Doucette, Quentin Rivera,
I didn't want to say it, but
Jack McLaughlin,
it's amazing.
Ian Monpetit, Angelina Nagy, Nick Nixon,
Her ability to not say, yar. I'm going to need. Like, I admire the restraint. Okay, what's this one factor to? We need two numbers that multiply to -3. Options are -3 and 1 or -1 and 3. Which is the one if it gives us -2? Yeah, so that is x minus 3 and x plus 1. And on the bottom, what are we going to get? Last one we need to do.
-2 and 1.
X minus 2, x plus 1. Everyone comfortable with that? X minus 2, x plus 1. All right, and now, what cancels?
1 and the 1.
X plus 1, x plus 1. Yeah, what else?
X minus 2.
X minus 2 times x minus 2.
X minus 3.
X minus 3. And what are we left with? X over x plus 5. There we go. Beautiful. Can I cancel these x's? Can I? Because they're invisible brackets, right? In other words, I would have to add 5 before I multiply or divide. So, nope, can't cancel. So that is the final answer. And what a beautiful final answer. You got to admit, isn't it a little satisfying to turn all this crap into that? Right? I love these kinds of questions, but they are tricky. There's homework here. You know what I would like you to do? Your homework. Please, 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 un cri de coeur. All right, a cry from my heart. Do your homework. Message me if you need help. Merci beaucoup. À bientôt. Avez-vous une bonne journée, mes amis. Merci beaucoup. Avez-vous beaucoup de Cheez-It? Ça, c'est très bon. Et un snack très délicieux, n'est-ce pas? And then like, yar. Could so-and-so Blackbeard please bring me Cheez-Its?
Blackbeard, like I love that.
It's my favorite name ever. It's so wonderful. I always thought my name was reasonably exciting.